All right, say again, please.
Yeah, I was just saying that the HDMI cables should be two. One is already connected to the laptop that is the top right corner on your desk, and it should stay there. This is for the queue. The other one should be close to the mics that are there on the desk as well.
I'm plugged into it.
You don't see that one?
I'm plugged into it. I'm plugged into it. That's the one I'm plugged into. It's plugged into a 4-way splitter, and I've got no projection.
Okay, so we'll come there.
Okay, thanks.
No worries.
Oh no. Oh no. Yeah, they're on the right. Thanks. So yeah, for everyone coming in, we are awaiting an AV fix. As you can see, this is the note well. This is an IETF. Yeah. The working group status is we have submitted so many drafts to the IESG in the past couple of days that they have blue screened our meeting. There's only so many blue screen jokes you can do in a row. So I am Brian. I'll have to be here all week. Actually, I do think I can start running through some of this stuff. I can put the note well up in a moment. So our working group status, we published 2 RFCs. Oh, actually, I don't have the updated chair slides here. That's unfortunate because we published 8321, IETF IPPM Altmark has now been published, and 8337, which was the last draft from our Orlando charter in March of 2013? 13. Okay. Yeah, so happy 5th birthday to RFC 8337, draft by IETF IPPM model-based metrics. So that is done. We have also submitted 2330 IPv6, so even though it's on the agenda, I have no idea why. Do you want to talk for a couple of seconds about what you did? Okay, good. And TWAMP Yang, TWAMP. TWAMP Yang 06 has also been submitted. So we've got 2 in queue. Thank you to the IESG for reading these. So should I plug back in? Oh, sorry. I didn't realize. Yeah, I unplugged. I think I'm connected. And on the agenda today, we have 10 minutes of fixing AV problems, followed by, actually, Al, you didn't have slides for 2330 IPv6, did you? No. No. Can you go ahead and we'll just sort of do the things we can do without slides. And I also didn't get slides for port TWAMP test.
Yeah, I'm going to do that without slides.
Okay, cool. So you can do the 2 things that you're going to do without slides. We'll jiggle the agenda around a little bit.
I'm glad to have.
Excellent.
Hi, everybody. We need a bigger room next time. It looks like I'm Al Morton, and a co-author of 2 drafts that I'm about to talk about. It's a good thing I brought my machine. So one of them is the update of our framework for IPv6 testing, and that is now basically done as far as the working group is concerned. But we had to update it a bit, and the reason we did that was because the IPv6 updated drafts in their large series dropped in the 8,000 K range. So we had to update. I guess Nalini noticed that. So thank you, Nalini, for running the the NITS checker to find that problem. And then we actually revised the text that refers to the references. So that took a little time. And then Neville, who's here, Neville, our document shepherd, found the same problems. Unfortunately, we had a working version like ready to go to fix those. And Joachim Fabini did most of the updates to the XML, and then once we all agreed to it, we submitted it. So that's why that one was updated and is now on its way. Good. So then, so basically, the last time we talked about, so now another draft, one I'm co-authoring with Greg Mirsky, who's here in the front. It's the draft IETF IPPM port TWAMP test. That is a draft where we're moving a UDP well-known port from an assignment to the TWAMP control protocol.
Wow.
Yay!
Al, sit down.
Can I do 5 more words?
Keep going.
Control protocol to the test protocol. And we believe this is done. It's the combination of 2 individual drafts, and so that's this should really be on its way too. And we've done what we can to accommodate it in the Yang model. I think I would like to have done more, but it was tricky. That Yang stuff is tricky. So anyway, thank you very much for the status.
Thank you, Al. Any questions on those two? There's a microphone. Might be easier to come to this one.
I just looked at that draft just before coming to the meeting, and I think there's a mistake. The port, the last one you talked about, the changing of the UDP port 862. I think there's a mistake in the table at the bottom that tells what IANA should do. It says, I believe, it says 861.112 instead of 861, 861, 862, 862. So just look at it, make sure what's written in that IANA, please assign this way. It says it has 2 ORAMs, 2 TRAMs.
Yeah.
And it switched 2 of them around. So
right.
Check that.
All right, I'll check it.
Cool. Thanks. Thank you for reading the drafts. So we actually we need to check on note takers. Roni, are you taking notes? Maybe. Can we get maybe a backup note taker in on Etherpad? He's on doing on Etherpad. We get somebody on Etherpad. Can you log in Etherpad? Okay, can you back up on Etherpad? Thank you, Tommy. JavaScribe. Huh? Oh, cool. Thank you to Miria for JavaScribing. Good. So this is our. Actually, why did I make you sit down, Al? You're up here for like the entire. So the next. So let me see. We got IETF. Okay, 2330 APP6 we're done with. Port TWAMP test. You're going to have a quick look at what's going on. Then we have the metric registry, initial registry, and then routing. And then we switch from the Al Morton show to the Greg Mirsky show. And he'll talk about stamp and the Yang models. And then we'll go to the IOEM portion of this evening's entertainment. There's Frank. Good. Okay, good. And then we go to the lightning talks. Quick question. Carsten Rosenhovel, are you here? Excellent. I did not get slides from you. So there's nothing to report. Okay, cool. Good. Cool. So then we can just strike that off the list. Yay. Thank you very much.
4 minutes for somebody else.
That explains why I didn't get slides. Okay, good. Thank you very much. So, Al, route or
Whichever you find first is fine.
registry?
Registry. Okay. Registry it is. Obviously, we've been doing this a long time. And so I'm actually going to concentrate on the contents of the registry first. Although there's a next slide, please. Oh, you got the thing? Hey, it's on now.
Yeah, here we go.
Yeah, good. Thanks. All right, so that Right. So this is the contents draft, and this is the registry that we're trying to put the contents in. And that's a pretty long one too. So we're trying to, the concept here is that we're trying to specify with precision metrics and methods of measurement so that folks can make these measurements all the same. And we're going to provide unique IDs and so forth, detailed exposition so that these things can be done the same way everywhere. This is a general description of the registry concept. Each registry entry is a row, no surprise. Lots of things that you can read there. I'll just hesitate for a moment. So the next slide shows the category and column headings. And so we have a summary, metric definition, method of measurement, the output, administrative info, and the full history in the comments. Lots of detail there. It's the same for passive and active measurements. Also hybrid measurements. So they should all fit in here when they matter. So here's the updates for both drafts. So we've revised the passive TCP metric, which was added in 13. We've added a handshake metric. This was previously the TCP SYNAC metric, but I generalized this to be called handshake because that kind of future-proofs it for the days when we're trying to do something like this with Quick, if we get there. And it's not going to be quick. So there's the name, round trip delay passive IP TCP-HS. That's a new naming element for handshake, and that's the one we can reuse. And then I'll note down there at the bottom that that we've also added Quick to the naming elements. So when qualified and corresponding packets are a TCP SYN and a TCP SYN ACK, that's when we get the round trip delay in the forward direction. We're assuming an observation point sort of in the middle between the two endpoints. And you get basically two halves of the round trip delay, the RTD forward, RTD reverse. Put them together, you've got the total. All right. So, oh, I went back. Sorry. Oh.
It's the same slide.
It's the same slide. All right. Wait a minute.
Yeah. Keep going.
Okay.
There we go.
Sorry about that. So registry and metric drafts update the future. Here's the future now. We really need to look at the heuristics for the methods of measurement in the TCP passive work. I said right here at Hackathon 101, we had a good discussion about the heuristics in general, and we examined sort of ourselves how the TCP heuristics would change when we look at Quick with a spin bit implementation. A spin bit basically means, for those who haven't become familiar with it, it basically means that you get one sample of round trip time sort of per window, let's say, per total round trip time. You don't get a round trip time for every packet. So that means that when we have when Brian has used in the past a round trip time window for evaluating round trip time samples for TCP, now we're not going to be able to do that. We need a larger window to do that. Brian's at the mic.
No, I'm already in line. Keep going.
Okay. So I've got a lot of items here which we recorded. I want to thank Emil Stefan and Alex, his colleague, for going through a lot of this with me. I think we collected a lot of good stuff here and ways that we can improve both the heuristics we've got for the methods of measurement and the future.
Okay, so comment from Brian before comment from Brian. On this, so there's the discussion on the spin bit is basically the whole scheduled agenda for Thursday morning in Quick. If you are interested in this, please come by. The method here is not really necessarily Quick specific, right? It actually looks kind of like an alternate marking method, but it's an alternate marking method where the alternate marking is dependent on transport state because of how the spin algorithm works.
Right.
We did some experimentation with this at ETH and found that it actually gives you better RTT measurement than you get inside the crypto in certain cases because of just the frequency of acts when you have unidirectional traffic. So the spin bit actually gets you more edges than you get RTT samples just looking at the act stream.
Wow.
When you're coalescing acts. So we're doing this work for Quick, and we're doing this metric work in Quick. And if the spin bit doesn't end up in Quick, then it's probably not extremely useful to put it in this registry. But the two different spin mechanisms, one is a 1-bit spin and one is a 3-bit spin, that we were looking at are kind of general mechanisms, right? You could add them to, you could put them on an extra bit in the, I mean, we have many extra bits in the IPv4 header. Obviously, you just grab one of those. You could have a gigantic destination option for your little 3-bit thing, which seems incredibly wasteful. But I mean, so the general marking mechanisms are generic. Yeah. So it might make sense to nail this down a little bit more, regardless of what happens on Thursday. Okay. I'm cautiously optimistic, but
well, I wasn't actually proposing that we take on Quick in this initial registry context.
Okay. But you need to make sure that the registry definition would allow us to come back and do it, right? Because if we suddenly move 90% of the passive RTT measurement in the world to the Quick spin bit, then
we'd actually need a new metric.
You'd need a new metric.
Yeah, because of the naming.
Right. Exactly. Yeah. Well, and the measurement methodology is completely different, right? Like, so the state you have to keep, the thing that you're looking for, the signal that you're using, it's all different. So, and the 3-bit spin is actually kind of, it's kind of weird and designed. It's designed to solve a specific problem that you run into when you're using a 1-bit signal in a environment where you have loss and reordering. Right. Okay, so it's not that weird, but I mean, it's a fundamental problem that you have to deal with in a packet switch network. Yeah. So, but yeah, so that all of the stuff for the registry for whatever ends up in Quick and other things that are parts of this sort of single bit explicit passive measurement signaling, it's hybrid measurement, right? Because it's a bit that's put in every packet for the purpose of passive measurement. All of that is, we'll have to basically do bespoke stuff for the registry to make that happen.
Yeah. Good. Thanks for your comments. So like I said, I'm not going to go through all this in detail, but you're welcome to read it and appreciate it. More updates. So this one we didn't act on yet, Brian, but we wanted to improve the DNS measurement methodology. At the last meeting, you mentioned that there's an interesting method for DNS measurement by encoding information in the query itself. We currently only have measurement for a specific RR. We could do more. And also, I got an email from Fred Baker from the Root Server Service Advisory Committee, RSAC, and they need metrics to support recommendations to root server providers. They're kind of SLA-like, and so it would help them if we did more in this space. It may be beyond the scope, like I said, future there. It may be beyond the scope of what we're trying to accomplish here now, but that's something worthwhile noting. All right, so next steps, we really need this TCP section 10 reviewed. I'd like to see DNS response time and loss also reviewed because I've got that quad @ symbol there. We have to look at two methods in order to be able to measure loss. And sort of the final thing is that on Thursday, I've been asked to come and talk to the XR block group. It's late Thursday afternoon. And they want to provide input to the registry. This was kind of a surprise to me, but glad to get it. I mean, actually, we had some folks from XR Block comment on the RTCP XR metric last time, so it's not completely unexpected, but it did come kind of as a surprise. Yeah, Rachel.
Yeah. Actually, that's me bringing this work to XR Block, and I think on Thursday we are going to discuss whether these metrics should be included in the whether XR Block should do this work, or if we do, what kind of metrics should be included?
Yeah.
Yeah. So
And I mean, there's a lot of ways this could proceed. We hold up the initial draft to try to get those metrics in, or we just have a follow-up draft that puts in the RTCP XR metrics that you guys are interested in. A couple of ways to do it.
yeah.
But let's talk
I
about
agree.
that Thursday.
Yeah, of course.
All right, and we'll promise to feed back to the group. Okay, that's it. Oh yeah, I wanted to mention this one. So now that we've got RFC, pardon me? What's the action item?
Oh, yeah, reviewers. Yeah, we should
Oh,
actually
yeah.
ask for reviewers.
Okay, who'd like to review? Okay,
Okay.
Yakov, TCP section.
Yeah.
Yeah, anybody? No, you're
We need multiple eyes on this one.
you're in there, and
I'll do it. Yeah.
and anybody for DNS really need somebody? Anybody know anybody who knows Ignacio? Good, thank you. All right. So this is one that we really ought to sort of pick up and get going again now that we've got an RFC, I think. And Matt and I will work that in our copious spare time. And that's my last thought on this. Thank you. Oh, Matt.
This document and actually the general problem of extensibility for the registry has suddenly become a worry to me. It feels like we're going to produce a huge population of tiny RFCs to essentially add one line in a registry. And it feels to me like a lot of those, in many cases, belong as a separate section in the base document, in future base documents. What I don't understand, does this registry require IANA action? Are there fields that need to be registered to be unique that might accidentally collide, so they need to be coordinated?
Yeah. And have you, I mean, and you've
Yeah.
looked at this registry entry. It's not small. It's not, I mean, a one-line entry
Yeah.
has a lot of detail. And IANA is ready to deal with that. It's not going to be an enormous table that you can't really use on your screen. It's going to be like a text file.
In which case it warrants being a doc.
So but then they're not one-line RFCs either, right? Like this is cutting out a one-line RFC. So, all right, I guess we can go on.
Yeah. To route.
So there's four of us doing the now interestingly named AURA draft, Advanced Unidirectional Route Assessment. I can say the names from memory.
Yeah.
So Ignacio, who's here in the front,
This is not great.
Al Morton, Joachim Fabini, and Carlos Pinataro. Well, I'm not sure who's here this time. I don't think he is. I haven't seen him yet. Yeah.
Okay.
So we're doing it, and okay.
Yeah, you know what? I need to
So
off and then back on.
so I'll just start with the background. We introduced this draft kind of a year after meeting Ignacio in Buenos Aires, and got some good comments from Rudiger Geib and Frank Bachner. We had a strongly informed scope discussion at IETF 100. We had proposals from Carlos to cover more than IP, basically to start to look at other layers and so forth. What we agreed was that we could make the definitions of a hop and a host identity and so forth. I'll get to those in a minute. We can make them more general, but we will consider what work is applicable at other layers as needed. And as I said, we had Carlos. So here's how we've generalized the definitions. So for the true scope, it's the internet and hosts communicating on IP. That's where this is directly applicable. But we're saying it's applicable to other network domains if desired. It's current wording. So now we've generalized terms like host identity. so that they remove IP from the first sentence and then make it specific for IP. So that makes it generalizable. Host identity, the unique address for hosts communicating within the network domain. It's a globally routable IP address for IP. This is the address that they use for normal communications and error communications. That error part is important. For discoverable hosts, it's hosts that convey their host identity according to the requirements of the network domain, such as when error conditions are detected. And that would be important when ICMP sends a time exceeded message when discarding packets. And it means it complies with 1122 and 1812. So now we're still generalizing the definitions and more. A cooperating host, it must respond and it should provide other info. And this is the interrogation kind of protocol. We'll hear more about that later from other authors. But this is where you're being explicitly asked, what's your address? What? Let's see. So in the remainder of section 3, we've really cleaned up all sorts of things, like the fact that the IP address and TTL and other terms appeared in various parameters. We've generalized those for hop, member root, and root ensemble. That's kind of the hierarchy of things that we'll measure and report here. So here's questions for the working group, something we can discuss. So can we add an appendix to illustrate applicability beyond IP? At the last meeting, Spencer, who's reading his phone, said that we should... Al. Yeah. Sorry. So consider first whether work needs to be done. And one way to do that is to kind of look at how it might be done in this context. So we think a candidate for an appendix that shows the applicability beyond IP would be based on MPLS ping and traceroute. Would use RC 8029. Can be applied to IP because it's already being sort of done in a V6 data center. And last time Greg Mirsky suggested 6374 for loss and delay measurement in this space. So that's sort of one topic to talk about. Any feedback on that? Yakov?
Another obvious appendix, if you're doing this, would be Ethernet, right? You have all the mechanisms to measure. It has unique addresses. There's obviously OEM that can do these things for you. So I think that's even better than MPLS.
Ethernet better than MPLS. You heard it here, folks. All right. Anything else on that? Okay. So reporting the metric. One point that Carlos asked me to make at this point was that we don't want to sort of fix something rigorous format-wise here. That when we make the measurement, there can be multiple ways to report this. We might have multiple options here, but we've looked at this, in various times and various places, and seeking some wise and experienced input on this particular topic.
Hi, Brian Trammell as individual. So one comment, there's actually an RFC for a storage format for trace routes.
Yes.
I don't think we want to do that.
Right.
Anyone who wants to understand why I say that, go read the first couple of pages of it. One thing that I think whatever format we have for this should capture is that you never, from any of the methods that we know how to do for route connectivity, you never get an assertion that node X is connected to node Y, right? You get an assertion that at hop X of protocol, you got a packet back from this interface, which is attached to device X, and then one TTL down from there, a few seconds later, you got a packet back from interface Y, which is attached to some other device, which might be the same. I mean, so like there's the standard thing that people do with trace routes is say, okay, every hop is a link and I make them a graph because that's cool and we have tools for dealing with it, and it's pretty much always wrong. So we should somehow capture in the format that we're not talking about hops. We're talking about measurements that at a certain distance at this point in time we saw this, right? And then you can infer what you want to from that, but we don't want to repeat the inaccuracy here. There's recent academic work in inferring interconnection among entities from traceroute data
Okay.
and BGP data. It turns out you need both. So
Hmm.
there's anti-aliasing. So there's a thing called Mapit and a thing called Border Map, and you can actually glue them together, and they work nicely together. But that gives you more an AS level interconnection graph and not a IP layer interconnection graph, which is
Right.
what and I don't think we want to do AS level interconnection in this document. We want to stay at the IP level, but we need to be very explicit about the fact that we don't have a way to actually measure what it is we want to measure. So everything we're measuring is a proxy.
But one of the side effects of MPLS is what you just said.
Okay, now I'm going to take that Ethernet versus MPLS hum. Yeah.
So Ignacio was raising his hand to comment on the two sort of BGP-based methods. So please.
Hi, I am Ignacio Alvarez Amelin, a Tech Fellow from the IETF. From the point of view of traceroute, specific at traceroute at IP level, normally we try to use some kind of useful tools that try to do the best to look forward the same path every time. But it's not always the same. You normally 99% of the time you can get the forward time, the same forward time. And not always the hop n and the hop n+1 are being connected physically. There are several things, for instance, MPLS tunnels, opaque tunnels you cannot detect, and normally you can get several hops in the middle and several things in the middle. And there are a lot of issues to make maps using traceroute. This is one of the things that I normally do. If you are talking about BGP, this is different things, but normally you can get some more information, because just to map the IPs to the prefix and prefix to the IS number, you can get some connections, some real connections. But normally you got less connections than you see the BGP tables at root views projects, because you more or less you got a lot of information there, and sometimes there are some informed routes that they are not being used because there are not problems or because another things. Therefore, if you want to make a map, it's quite difficult. This is the best that we can do. It's not, but it's not perfect. There are some bias at the end.
Right. Yeah. So we need a sentence right up front. This isn't perfect. Thanks. All right. I got it here. So we still have a sort of Rudiger.
Yeah, I'm Rüdiger Deutsche Telekom. One remark, if you work on MPLS or an Ethernet, this would delay your draft, I guess, because you need the expertise and it needs to be sober, and it will be different from what you write on IP, because in order to make sure that packet passes the same link on MPLS, you do something completely different than you do on IP, as suggested by Ignacio. So
Okay.
maybe you should only write, one could do that for MPLS, and then this will be another document.
Yeah. Okay. We wanted to ask. Thanks for the input. All right. So we still have lots of things to do. A lot of them were suggested by Carlos when he was a commenter and not a co-author. One by Frank Bachner's there, and then we skipped that last one. So we'll keep those in mind. Got to get those solved. For another discussion area, it's the temporal composition for root metrics. Past measurements influence current results. This is pretty well understood. If you measure something now and it doesn't change, it'll be the same route. So can we spot check past measurements at critical hops where they have sort of diverged into multiple parallel paths, and that way reduce the measurement load and time? That's something I think we should think about. I'd like to sort of hear from folks in their route measurement experience, whether they found, how much stability they found in their little corner of the internet, because as Matt pointed out rightly in the last meeting, what you've seen of the internet is different from what everybody else has seen. So you really have to ask the question in the broad context of this crowd here. So there's other things that we should probably develop. I like the idea that the hop and route concepts, they sort of treat a class of packets, what we call class C. We treat them equally. They all get routed on the same path typically. It's useful to know. It's a concept from a couple of RFCs that we've had in the past there, all the way back to 2330 and the newer 77 to 99. But I think that's sort of worth thinking about and doing more with here. So let me leave those errors or areas there. So complete the to-dos and continue development and discussion items. But here's where, thanks to Ronnie's good reminder from last time, let's try to line up some reviewers for the draft, especially sections 4, 5, and 6, which are Ignacio's main contributions to this work, and which talk about the methods of measurement, talk about the tools that can make these measurements, and the delay analysis. So that should be fun. Should be a good read.
Ask an explicit question. I think you need to wake them up.
Who would like to volunteer to read sections 5, 6, and or 4, 5, and 6?
Who in the room has done work with trace routes?
Jason.
Jason has done work with trace routes.
Jason Wheel.
Done trace route stuff.
So he'll take a look. That's
He'll
good.
take a look. Okay.
All right, that's a start. Jason, Jason, W-E-I-L, yeah.
Good.
Good, thank you. All right, I think that does it. And the only other thing I wanted to talk about as I go away was this hop count tool that you and Yari and someone else are putting together. I think that's worth talking about as a methodology in here.
I'm not sure yet.
Okay.
That's really researchy stuff.
Okay.
So for actually I shouldn't say too much because some of this will be discussed tomorrow during the plenary. But a side project off a side project was a Yari primarily is putting together sort of as a side project a tool to figure out efficiently figure out what the path distance between two points on the internet is. So it's basically like traceroute, but it tries to send fewer than a traceroute's worth of packets. And it caches things, remembers stuff, and so on and so forth. So,
yeah.
So hop distance is an interesting, like, not the actual hops in a traceroute, but the number of hops in a traceroute is an interesting secondary metric for doing classification of primary metrics. So, for example, there was this thing that I did for the quick RTT design team, looking at how privacy sensitive location information was coming off of RTTs, and it turned out that if you were getting information from trace routes and you knew how far away something was, the lower the hop count, the more likely you were to have better fit between distance and delay, simply because there were fewer points at which you were going to have processing delay, right? And
Yeah.
fewer points at which you could have queuing delay. So as a metric, it's kind of interesting. I don't know that we really need to cover it now yet because it's kind of just a little pet project. But
Okay. Well, I think we'll be working on this for a
Yep.
while, and,
Yep.
and I know you work fast, so thank you, Brian. Thanks everybody for your attention. Ignacio, you can.
Yes, just a little comment about the last one. When you do some measurements using TCP or Quick or whatsoever, the difference is the way that you are gathering the information. With traceroute, you say, okay, I will gather every second or every fixed time, deterministic time. And this is different. You got less resolution. You got much more resolution in the other case. But from the statistic point of view, you are not doing exactly the same.
Yep.
And this is a special point. Just
This works. It should.
Okay, this is a combined deck for stamp base model and Yang data model of a base specification. Oop.
Is it not? Hold on. Which one is forward? That one should be forward. There you go.
Okay, so since we already discussed what became zero version in Singapore, I only give you diff. We welcome Richard Footy. You know him as a footer. He provided very good comments and helped us to advance this version. So we expanded introductions section, did update on the terminology to make it more, I goofed, to make it more familiar those who work with TWAMP, and make it less SDN-centric, so that to point out that control of stamp entity can be provided from OSS, BSS, proprietary CLI, or SDN using netconf Yang, and clarified use of Z field of error estimate field that based on our RFC that we have to support PTP format, how it interoperates. We discussed among authors and decided so to make this document leaner and enable faster progress of the document to spawn stamp extension document. And stamp extension document will be presented in the lightning section. And we added section on interoperability of with the TWAMP light. So in interoperability with TWAMP light, we consider two scenarios. Obviously, it's a heterogeneous system when we have stamp session sender and session reflector on TWAMP light, and conversely, a TWAMP light session sender and stamp session reflector. We document how it works and what can be used, and I just don't want to read it. I appreciate if you can take a look at their published document and send your comments. So what we see as an open issues is security. Encrypted, authenticated mode, what we want to support in stamp, because as we discussed in the previous meetings, the goal, the requirement we set for the stamp is to be compatible with the TWAMP in unauthenticated mode. we think that achieving compatibility on the wire with the TWAMP encrypted or authenticated mode, it's too high requirement because of the way how encryption and authentication negotiated in a TWAMP control protocol. So input suggestions, your thoughts on security are greatly appreciated.
Yeah, Yakov Stein. Number one, I think that's fine because the use of the authentication and encryption in the field is actually relatively limited. The encryption, I personally never understood why anyone would want secrecy on a test packet anyway. The authentication makes sense, but as I said before, it's really not that used. So losing the ability to interwork with a system which really is not that much in the field, I don't think is a major loss.
Okay, thank you. But what we want to do and how much we want to do? We want to do both methods, or we'll be fine with one of them? Because the difference is that whether their third time, or actually their information collected by the reflector on ingress to send in the clear text or to be protected as well. So that's the only difference between two modes.
Yes, understood. As I said before, I'd really like to see someone explain a threat model, why we need encryption on this kind of test packet. We did a similar thing on timing packets in TikTok, and no one really came up with a credible explanation.
Okay.
Authentication, absolutely. It could be either service stealing of this or doing bad things, and that I understand. But encryption, I don't understand the use case, and therefore I think you can just forget about it. If someone really says that they need that, put something in. It doesn't have to be compatible with anything.
Right. Okay. So okay, we agree on that. Compatibility may not be a requirement; is a non-requirement. I think that the only possible scenario is that because now monitoring SLA becomes a part of lifecycle orchestration, and failing out of SLA may become some event that system will react. So man in the middle mingling with your measurement results can affect your view of quality of the service, which would not be objective because it will be skewed.
And I think actually you're actually giving a good proof of the opposite, because if you're going to look at an LSO monitoring system, if it's encrypted packets, then you don't really know how to monitor unless you push the keys into the middle of the network, which sort of is creating a problem that probably says that the encryption is a bad idea. So yeah, I understand what you're saying, but you can read it the other way as well. So all I'm doing is agreeing with you that right now it's a non-objective, and I think it's your suggestion was fine.
Okay. So, but again, then our call to the community is to look at current document, because we just effectively replicated the format of the packet as it is in TWAMP. So is it something that we want to carry on, just knowing that these packets would not be compatible with the TWAMP in encrypted authenticated mode? Because what we would like to do is we would like to progress this document as rapidly as possible.
I believe that if you look where it's going to be hard and to update previous or existing legacy reflectors, the hardware reflectors, as far as I know, none of them support authentication or encryption. The ones which are software can be upgraded.
Mm.
So once again, I think it's fine.
Okay. Okay, update on a Yang model. Again, in sync with their terminology update we had in the base model, we provided this update. We changed their stamp security to stamp authentication, vice versa. Stamp security replaced stamp authentication. And define new timestamp formats to be used in connection with their use of Z flag in an error estimate field. And provided some extension for the stamp session reflector in order to take advantage of default values and minimize the necessary configuration for the reflector. And that we added configuration examples to demonstrate how the default configuration will look on or minimum configuration on the sender and default configuration on a reflector. Question?
No, not a question, just a comment. Once again, because of my not having been in several IETFs, I missed this document until you told me about it. And I just wanted to say how impressed I was with the Yang. The company I work for, we have a proprietary Yang for similar purposes, and this is much more complete. I was really impressed with it, and I really like the idea of having another timestamp format for those who like, similar to what was done in other places in the past. I think it's a great idea, and to allow both the NTP kind of format and the PTP kind of format for those who need it.
Yeah.
So I think both things, number one, great document. Number two, that's a good idea.
Okay, thank you, Jakob. But again, I regret that you missed that we do have RFC for this timestamp, PTP timestamp. So basically, it's not really that novel idea. It's just taking advantage of existing RFC.
I understand it's not now. I mentioned that this has been done in the past, and I think it was a good idea then. And borrowing that technology and bringing it here is a good idea. Fine.
Okay, thank you.
And you understand why I think it's a good idea, not because of the problem of round off. The problem of leap seconds is the problem.
Yeah. Okay, again, it's too small script. I cannot read it from here. I have to acknowledge that. But yes, please read the document, or you can do a diff with the 0 version, 1 to 0, and take a look on only of diffs, and review what we've changed and commented it, whether you like it or not. Yes, we split a little bit different. We introduced for the reflector, we introduced that reflector can take that it will take the session on any port and from any IP address. So that really, it was a suggestion from Footer, and it really made the reflector configuration in the default mode much simpler. Of course, that creates a security concern. So because then the stamp does not filter incoming stamp test packets, but that can be mitigated by using ACLs. So outside of a stamp, it's just a matter of preference. You can use ACLs to filter traffic that is destined at a stamp, and especially that is easier because if you use a well-known port 862 that we make in a default for reflector, then it makes it much easier to put up ACLs and then make reflector configuration minimum as possible.
Just a comment on that. Yes, you can look at this as being an ACL kind of problem and therefore handle it that way. I think, however, that there is a good reason to think of sessions even in TWAMP Lite or stamp in this case. And when you think of it as a session with session parameters, it's not an ACL problem anymore. And the most important parameter of a session is who the sender is. So therefore, I understand it can be done, but I think it's the wrong way of looking at things. It's sort of looking at a reflector who doesn't know what it's doing, has no concept of a session, and you're ACLing it. I think that's, yeah, it'll work, but I think philosophically it's wrong.
Okay, I can point to BBFTR 390, which is a similar idea.
And as you know, I thought it was wrong there as well.
Okay, I don't argue. But again, I want to stress that this is optional. So this is not the only way to do reflector. Yes, you can do it very explicit configure identity of the senders on the reflector. Of course. In the same way, you don't have to use 862 UDP port on the reflector. You can pick up any port from the dynamic range. So that, again, provides the backward compatibility with the TWAMP wide sender or TWAMP sender in a unauthenticated mode. Okay, so again, we can discuss whether the choice of default is reasonable, that using any as a default setting for sender port and address on a reflector.
From the point of view of default, once again, going back to security, from the security point of view, I believe that even a quote-unquote dumb reflector should have the concept of a session. Otherwise, you can overwhelm it by sending, in this case, port 862 added from unknown places and just overwhelm it, and then you don't get response from it. Here's a security problem. Do it the right way.
I agree. You have a point. Okay, so that's an example of session setter configuration. We on purpose left everything which will go away because it's basically default, just to demonstrate that, and you can deduce, or we can just produce the real configuration, how a small configuration would be if we use the default settings. So this is reflector. And effectively in the reflector, if we use, if we move the problem of security to ACL, then it's only enabling the functionality, and default is 862. So that's it. We welcome comments, questions, and we would like help from chairs to get an early young doctor review.
All right, I'll note that down and make that happen.
Thank you. Okay, I don't know if I spend time or I save time.
We're actually way ahead. This is pretty cool, but you're welcome, lightning talk guys. Yeah, you're welcome, lightning talk guys. I can't remember when we've been this far not behind at this point in an IPPM meeting. Frank. Eight. So.
The suspicion that's also moving faster. All right.
Here, I think, yep, there you go.
Do I need that? Maybe. So update on the IUEM data fields draft. I'm sorry for that. I tended to go and copy that title slide. It's corrected on the draft, by the way. So the draft has even David's new address. So sorry for that. Good catch. I'll correct that for the Montreal meeting. So there is, I think, two main changes to the draft as it stood. The first thing is, and we had quite a debate in Singapore on that, timestamps again. That we had, well, a need for more than one timestamp format. Some people argued for 1588, some people argued for NTP. There has been more recently even an argument for POSIX timestamps, and people not only wanted to use the timestamps for hop by hop, but they also wanted, so for tracing, but they also wanted to use it in an end-to-end way. And we wanted to harmonize that instead of having multiple things flying around. That's something that we've done. And the second thing was something that we learned from writing a series of different encapsulation drafts, and that it helps go and harmonize the data structures here to go and allow us for an easier way to encapsulate things. And then, well, we did a load of cleanup and That's not really. Oh yeah, yeah. I need to go point it that way. So on the IOAM type thing, that's apparently something that, from a problem perspective, Brian brought to us, and Brian started writing an encapsulation draft for GRE, and well, then he started doing that, and he found out that with the original approach, how data was structured, we had a OAM type field for the two versions of tracing, incremental tracing and pre-allocated tracing. What we didn't have is a code point in the IOAM data draft for end-to-end options or proof of transit options, which means from a parent protocol perspective, you needed 3 code points. One for tracing with the 2 subtypes then, one for proof of transit, and one for edge-to-edge. Now, he went to the IEEE and said, well, guys, I need 3 either types for that. And the IEEE guys said, no fucking way. Okay, problem, right? So that pointed to an inconsistency that we had from how we did typing in our IOM data draft. And well, that was the incentive to go and clean that up. So we've expanded the type now to go and cover all 4 cases that we have. And well, that leaves room for additional types in the future so that we have a dedicated type for pre-allocated trace, for incremental tracing, for proof of transit, and for edge-to-edge. And well, there is now room for multiple additional types if we ever come up with those in the future. And the other benefit is that we have a single code point from a requirements perspective. When we ever ask a parent protocol, go and encapsulate, and we'll see that in a sequence of additional things later on. So I think that's the benefit, that we can go and harmonize single code point from upstream. And that obviously solves the problem with the GRE draft immediately. We only need a single either type. So there's a question.
Just a comment. I'm glad you have made this extensible, because I have another option here having to do with proof of transport. But you know, POT as presently defined does not check order, just that it goes through the different points. And I have made an extension to that, which also checks at the same time order. And once again, not right now bringing it to the IETF, but at some point I will be, and would need another point.
So just as an FYI for you, so the current POT draft that we have has 2 ways to go and do proof of transit. One is based on Shamir secret sharing,
right,
which doesn't allow you to go and check the ordering.
Onion routing,
and the second thing is based on the second option that is mentioned in that draft is basically based on nested encryption, which allows you to go
onion
and,
routing, right?
Which allows you to go and check ordering.
I can do it based on secret sharing, but with order. It's a
Cool.
slight change of the polynomial.
Okay.
Because
Fair point.
the
So-
onion routing way of doing is much heavier from the point of view of computation.
That's correct. So that's an interesting, so let's chat offline, because so far we had that trade-off discussion in POT, like if you do crypto, then you need typically hardware assist to do that in an efficient way on every single packet. If you do Shamir secret sharing the vanilla way, like we did it, then, well, you lose that particular attribute of being able to check sequence. And okay, well, let's chat offline, because that might be the perfect middle way, because people have been arguing over proof of transit. 2 options, not great. Options are awful because it leads to duplication in implementation. So that might be a good option to go and explore as a kind of a solution option. So, well, that's what we've done so far. So from a cleanup perspective, encapsulation now is far smoother. And you'll see that later on. So the basic ask for every single encapsulation, for every single upstream protocol that we have, is for a single code point. The second thing goes to the timestamp format. What we've been harmonizing is there is now a single section that discusses timestamps. And So we've been farming out the text that was kind of scattered around in incremental tracing, in pre-allocated tracing, in the edge-to-edge option, and we farmed that out into a dedicated section. And in that dedicated section, we cover now, well, the three typical uses of time from a format perspective, be it NTP, POSIX time, or PTP 1588. There is two fields for that, seconds and, well, something that could be seconds and something that is less than a second, which could be nanoseconds or fractions of seconds or, well, I think the last thing with POSIX is not really microseconds. But the way how these fields are interpreted is up to the choice of one of the three. And it's up to the operator to decide which interpretation to go for. But we allow for these three. Now all these sections that we had prior are now referencing this one new section that defines timestamps. And that way, well, I think we harmonized anything time in that document, and well, hopefully it's cleaner by now, because that caused confusion in the last meeting. And finally, we've been getting a load of help from Mickey. Mickey is online. Thanks, Mickey. Cleaning up the language in many cases. That's kind of the Denglish thing because of me being German. And we also cleaned up things that typically confused people. You know that IOM had a little bit of, from an implementation perspective, heritage from IPv6. So we used octets left, not too great because it started to confuse people. So those things became their own nomenclature now, where you're using things like the remaining length to avoid potential confusion with upstream other protocols. That's basically what we've done on the data draft. Any questions, whatever? So that leads me maybe to the last slide. This way, through my back, then it flies. Well, please continue to shoot your comments. Trying to get this thing stable. It's starting to really look clean by now. There's two areas that need clean up. The security section needs a load of additional love. Hoping to get that filled in over the course of the next couple of weeks. Same goes for the manageability section. And we have a section on IOM data export there that I'm about to go kill because Mickey, with a couple of other guys, including myself, wrote a draft that covers a very, very, very simple way to do export of IOM data, which basically kind of takes the IOM data, wraps that into an IPFix frame without additional interpretation. So we're not really doing formatting into fields.
It's one IE or?
So?
Sorry, I should do that.
All right. And we just farmed that out into a dedicated document. So we probably don't need that thing in this particular document anymore.
So clarification question on that document. It's basically just, there's you have a new IE and IPFix that says, here's a giant chunk of IOM data, or?
Correct.
Okay.
He just published that. We couldn't get that prior to the deadline, so he just published that. Don't want to discuss it right now. Just make everybody aware.
Come talk to me as an information element expert about that at some point. We should have that discussion.
Yeah, I think this makes the call for 2 or 3 additional allocations that we need from IANA. It's an informational document to kind of frame the discussion a little, so that we don't really have it in the data draft because it doesn't belong into the data draft. We're running 15 minutes ahead. That's cool.
Great. Questions? So I have a chair question. You say targeting a stable document by IETF 102. Does that mean you want to start the working group last call in Montreal? Or
let's see whether we can go and get there. So like, we have a little bit of homework there, and
so that
if we have the homework done by then,
Targeting a stable dock is an aspirational statement, not a promise.
Is an aspiration
Okay, cool.
statement, right? Yeah. So if we can get that done, yeah, that'll be nice.
Good.
If we can't get it done, like, yeah.
Yeah. All right. So next, I think we go into lightning talks, and that's still you, right?
Well, I don't know the order, but could be me. Would make sense
Good.
because that's touching on
Yeah.
the very point that I just made about
9, 10, 11. Yeah.
getting to a single code point per, or the possibility to do a single code point. And again, gosh, again, the same title slide.
Yes. Still not at Mellanox.
Anyway, so let's skip across that real quick.
Greg, Al. Greg, Al. Yeah. Sorry.
So baseline, what we want from an overall encapsulation perspective is people will do this already in hardware. So there is running code in hardware today. And that means whatever we do from an encapsulation perspective, if the protocol, the upstream protocol allows for choice, let's not make their life or let's not make the implementer's life in hardware too hard. So that's one of the mantras that we've been being preached. So avoid nested structures wherever possible, because pointer lookups in hardware are difficult and challenging because you need to do that at high speed. The other thing is what we learn, and I already talked about that, is make sure, or you can only in many cases use a single code point from upstream. Well, we've been evolving the data draft for doing that. So with that, we can pretty much have an encapsulation approach for all the protocols that is very consistent, because all we need is a single upstream code point. The question is only, what is the upstream code point? In certain cases, there is choice. The one area where we have choice is pretty much the debate that we have tomorrow, which is in NSH, where you can either go do next protocol or use TLVs. Here, I think it's even simpler with the protocols that we're discussing here. The other thing is that IOM is not expected to alter really the forwarding behavior of the packet more than it needs to. And that means whenever we encapsulate into a protocol, we don't want the traffic to be flagged as OAM traffic, because it's customer traffic. We're just adding additional metadata to customer traffic, as opposed to we are creating OAM traffic. This is not probe traffic just because we suddenly add the IOM information. And that means, well, we want to make sure that, well, that distinction is clearly in there, because many protocols have a notion of OAM traffic. And that's nothing that we really want to go do. The other thing is that we want to go and keep IOM of what it does relatively separated from the parent protocol, right? So the semantics that IOM has don't necessarily need to be known, and vice versa of the parent protocol. Because people might want to go and do the IOM operation in a blob. So all you do is, well, you hunt for the IOM information in the packet and then do the stuff on the IOM data, because the IOM data is defined with its own namespace and largely independent of what the parent protocol does. So, Brian, do you want to go do that? Because I've been keeping talk. Come on.
You can get up and say something if you'd like to say something here. Yeah.
Okay, well, I'm Brian Wise. I had a use case for the end-to-end case with Jiri, and so I ended up inheriting a draft, as it goes. So, so that became useful. Which button do I use? There we are. And that did help us, I think, understand how to clean up the encapsulations a little bit from what was there, just because it was something that we finally had to really focus on. So this is really simple. There's just one new code point, as Frank was saying, which is that says this is an IOM packet. And then there's a shim that defines the IOM, what's going to happen next in Jiri. And then you immediately go to what's defined in the data draft after that. So there was an intention here of not redefining whatever was in the data draft, but point to the namespaces. And I think we've gotten there very nicely. And then, so we've really just defined one little shim. Yes.
Yes. Hi, Greg Mirsky, ZT. Okay, I think that I can just give this question, and it's applicable to all three drafts to be presented in a lightning strike, so not to repeat it. Are you familiar with the overlay OEM design team OEM header draft?
I am not. I am. Okay.
Okay, so it proposed exactly the similar solution. It's just fields and size a little bit different, but idea is absolutely same. And this draft will be presented tomorrow and called for adoption. And if you're familiar with this work, I wonder why it's not even referenced in the documents.
Yeah, absolutely.
And again, why have three documents, and why have these documents at all if we have one draft that already will be presented and adopted possibly in NVO3 working group?
Well, I wasn't aware of it, so I can't answer the question. We'll look at it. This is the only slide for this.
This is the only slide.
Okay.
For that, right? Yeah.
Any other
I believe
questions?
So, right? Just click on. I think it's, yeah, the next one should be get another.
Yeah, because the idea of, and actually the charter of overlay design team was to produce OEM that can be used in different overlay networks. And so we have that, and we came up with one single document, and now we have three different documents that propose the same construct, whereas their construct is the same, which is not surprise to me because I know that it can be same. So I just wonder why need for three different documents to begin with, and then why not to use OEM header or comment on it, make it more suitable for your needs when we have already a document.
So, one quick one on that. So, we are not, so that if you read through the documents, right? So the encap looks similar, but it's not entire the same. That means you have to go and come up with something, that little shim that is protocol specific. Right, so if you look at, and I think we're repeating, maybe we'll just go and quickly skim through that. That was the GRE shim, where you're using Next protocol. You need something that gives you the IOM type and the overall length of this body, right? That's what you're doing in GRE. If you are in VXLAN and using the shim header there, you end up, again, using Next protocol, and you need a shim that encapsulates your IOM data, right? It's slightly different. The approach is the same, but I think there is no such thing that you can use a generic header for all these protocols, right?
You very easily can, because if you not limit yourself, we struggled with this when we tried to fit it in 4 octets. But when you go in, for example, for 8 octets, okay, 2
That's
words.
exactly what we're trying to avoid.
Why?
It's 4 octets.
Oh, come on.
We had a lengthy discussion about these 4 octets.
Actually, your solution is limited because you limit yourself only to 1K of IOM data, okay? So if you have more than 1K OEM data, what you want to transport, you are in the same problem you have with the TOV, with the limited length, okay? So why to offer limited solution when you can get throw another 4 octets, and then the sky is the limit. You have all the flexibility you need. You even have reserved field. You have a versioning. You have everything.
Okay. Yeah, I think that's the debate that we had internally.
And
so
I would like to have this debate in NVO3 working group.
Yeah, well, we can have that, right? So
I think we, yeah.
Which is why we're coming here, right? We want that debate. So we've been arguing this for quite some time from an efficiency perspective. So Greg is in I want it in the most clean way as possible camp. We can also argue the thing from let's do it in the leanest possible way camp way. Originally, why did we arrive at using not a single code point from upstream, but 3 originally? Why was it that way? Because we try to go do it as kind of condensed as possible. So if you're able to steal stuff from upstream, you don't have to go and define it yourself, which ended up being more efficient on the wire. Here, well, we're trying to go and walk this fine line between cleanness and efficiency. Yes, we can spend another 4 bytes, but we already know, even today, that certain lookup engines are relatively constrained how far they can go and look into the packet. Certain lookup engines today, from an IOM perspective, only support, say, timestamping, for instance. Why? Because they're limited in their lookup depth. If you're looking at use cases that are just caring about end-to-end timestamps, and you just want to go slot that in, and certain use cases do that, Brian, right? Then, well, this lookup depth becomes a constraint. So people wanted to go and have it dense. If we find consensus that, well, we want to go and spend extra bytes for getting more flexibility, I'm all for that if we can get, well, the entire party behind that. Because here with VXLAN, yeah, fine, we go with the next protocol approach. But if you fast forward to Genève, it's getting even worse, right? Genève is a real headache for me, because if you do Genève, well, you can't really do next protocol because that thing doesn't exist with Genève. What does that mean? You're using the TLV approach in Genève, and then you're limited, because of the 5 bits, to a length of maximum 128. That's far less than 1K, Greg, right? It's significantly less, and might even be too few for a load of generic use cases. So it is a concern. Can we solve it? Yeah, we can solve it with more bits. Are people ready to go there? Well, I think that's what we're trying to find out here. So we, so far, we're in the camp to save bits and not to add flexibility.
Okay. I would like to ask a question. So you propose to discuss data plane encapsulation of the packet that defined by other working groups. So why this discussion would be in this group and not this appropriate groups that own this encapsulation?
That's a recommendation by the chair of this working group. Maybe the chair of this working group can speak up on that one.
So the recommendation here is that we have, basically this is in parallel to the process we used with the 6-man or the IPv6 PDM-DO. This was a destination option. It was designed for use for passive hybrid measurement in IPPM. The proponents took that to 6-man. The IPv6 people looked at it and said, I don't really get the use case, so no. They came over here. I mean, the original idea was, okay, we're going to do the encapsulation over there, and we're going to do how you can measure things with this over here. Do you want to AD interrupt?
Yeah.
Okay.
I want to clarify the process. So it really depends on the protocol. For V6-man, they actually even believe, they say it in the charter, they say, we don't have to look at all the options. If you have a use case, you can define a new option, right?
Right.
So for other protocols, you really have to check the charter of the respective working group.
All right. Can you do that homework? Check
Yeah.
the charter of the respective working group?
Contact the
Yeah.
chair.
Yep.
Yeah, we can do that.
Okay. So yeah, I suggested that they come over here to talk about them because exactly for this particular problem, right? The different encapsulations have different limitations on the applicability of the data. And like, so it's, it is interesting to know that this proposal for Genève, for example, limits what you can do with IOM, right? So there are restrictions on the, and that is feed into the sort of the process of, how we define measurement methodologies and metrics based on this. So yeah, clearly the idea here is not an end run, right? The idea is that things come in here, we discuss the impacts, but the owning working groups obviously have to ratify any change if they own that. But if the charters of those working groups say that any additional code point within the protocol defined by this working group must be a working group item, then we have to do it that way.
Because I just wonder what will be the situation if their overlay OEM header becomes a working group document.
So it's obviously it's not extremely efficient in terms of documents if we have two different encapsulation methods. But if what I'm hearing from IOM here is that overlay protocol does not meet their needs.
I just suggest to work together
Yeah.
and give
So
their
We
comments.
can look at
Let's
that, right?
let's
So
take
I
the rest of this conversation to NVO3 tomorrow.
Yeah, we can do that.
Good.
And that's also why we took it here, because, well, you have the people in the room that care about the data that we carry, as opposed to you go to a working group that just says, well, we basically want room for a container. And well, what is in the container, people don't really care about, right? Because it's the semantics of what is in the container, the upstream protocol, not necessarily cares
Frank,
about.
I would not misrepresent the position of other groups, please.
Sorry, didn't get that.
You misrepresent position of other groups.
Let's take this one to NVO3, please. Okay, my watch tells me this conversation is over.
So it's-
Next is
on the process side, it's good practice to discuss it here first, find agreement in this room, and then bring it to the working group that might be responsible for standardization.
Okay, thank you.
And we got our answer.
What worked for us in PDM and
Yep. And actually, we were basically told by the 6-man people, yeah, you can actually do it over there. Like, so even, actually, I don't even think it was the 6-man people. I think it was Brian Haberman as interior AD. He's like, yeah, we don't care, but you might. Next up is Greg. Huh? Right in the notes, this conversation will continue in NVO3. Yeah. Full screen.
Okay, so as I mentioned, we split their document that was adopted by the working group and into two documents: the base specification, which defines the base format of a stamp test packet, and extensions. The extensions that we are proposed to use TOV type length value format. And some of these extensions already been the part of stamp document. It's padding, location, timestamp information to communicate or characterize their synchronization source and timestamping method. I personally believe that the idea of error estimate was to provide this information, and somehow we haven't finished the job of quantifying what is what. So if somebody believes that it's better to finish the work with an error estimate to characterize the source of timestamp and method of obtaining the time value, like how close it's hardware, it's a software or not, then this might be an alternative that we're planning to work on. Class of service, it's just has two options: whether just reflector reports of DSCP value and ECN value as packet being received, and puts it as a sender DSCP and ACN value, or there is an extension to that sender includes the value of DSCP to be used on the reflected packet. So that allows you to run DSCP testing, because you can, especially in multi-service wireless backhaul, when you have different services, 2G, 3G, and 4G, you often have to manipulate with classes of service marking. And sometimes this configuration is manual. It's very easy to misconfigure. And that leads in very difficult scenarios that it's hard to troubleshoot and identify the problem. So this mode been seen as a way of very easy test of the network to verify that their handling of DHCP values in both directions is as expected.
Hi, Brian Trammell is an individual clarification question. As I recall, there was a RFC a little while ago that added this to TWAMP, right? So this is basically taking that functionality from TWAMP and adding it to STAMP,
Okay,
correct?
yes. We only added to the monitoring. We have RFC to do monitoring.
Got it. Okay, yep.
But there is an extension to do testing. Yes, we use existing functionality and we take a next step, which I think is a logical step.
Yep. Yakov Stein, do I understand that you're going to be, or at least allow changing, let's say, DSCP on a packet-by-packet basis? In other words, have it jump around like that in a crazy way? Once again, the obvious idea of having a session, as in TWAMP, then you can, per session basis, you could do that. But here you're doing something which is just packets.
Yes, you're right. That's the idea, to allow to do DSCP test session.
No, but this is not a session. This is in the packet. So you could do this. One packet has this DSCP and next packet has another one, right?
Yes.
And okay, you're allowing that. Maybe we should put in wording that you shouldn't use it. But if you do use it, what do you expect to happen? Do you expect everything along the way to be stateless?
Well, again, if there is some cost remapping in the path, then we want to expose it. That's idea of it. It's a test how this path handles DSCP of particular value. Whether, because again, it's hard to say whether remapping is appropriate or erroneous. By sending packets with a set of predetermined DSCP values, we have certain expectations how that has to arrive to reflector, and if sent from reflector to the sender, how that has to arrive to the sender. So it's a controlled environment.
I actually just thought of an interesting test that I didn't think of before. If you have values like this, you could just start increasing the DSCP, then see all of a sudden delay changes. It could be an interesting diagnostic test.
With it,
I didn't think about.
No, with the
I'm
thing,
not sure I like. But
no. The thing with DSCP is that it's not contiguous space. It's a code point. Okay, so basically the idea is that
it's not PCP and Ethernet like I would be used to, but you could probably think of other things of that you could change on a packet by packet basis, which might make sense. I don't know.
We are open to suggestions, but the idea is that if operator has a notion of certain behavior they want to system to produce in regard to the DSCP, so you can have a test sample which is subset of your code points, depending on how what's enabled in the network.
But once again, why don't you do this in your Yang, set it up as a session and do the DSCP that way, have it reflect in a certain way, and not push it into the packet?
Because we don't want it to do it configure packet by packet with the Yang. Go change everything.
Exactly what I'm saying. So you are thinking of the packet by packet. That's an inherent part of this, that you're going to change it on packet by packet.
Right, but we can do it only on the sender, and reflector will just follow whatever it's told. We don't want to complicate Yang model on a reflector, okay? Because reflector should not be aware of it. Reflector should follow instruction given by the sender. Sender anyway will be analyzing, processing, or sending this data for the post-processing somewhere.
And the same for size of a reflected packet for the asymmetric case.
Yes.
And
So it's one, and then we'll go on because we're.
This is Footer with Nokia. I think the general comment of a packet by packet, correct me if I read this wrong in the draft, but each packet that relates to the session from the sender is going to have a consistent diff serve code point.
Yes.
You're using this on the reflector for congestion notification, something along the path. So it's packet by packet, but if the session sender launches each packet in the session with the same diff serve code point, then it is by session, right? It's just an action on the reflector.
Right.
Okay.
And direct measurement, so we actually direct measurement is the idea is similar to well-known Ethernet loss measurement, where you have a definition of what is in profile frames. So that for layer 3, it will be in definition of in profile packets. The exact definition is obviously outside of this specification, but their service that we provide, we just collect counters from the sender reflector in one trip of packets similar to Ethernet LMR. So next step, again, we welcome comments, and we kind of hope that it might be grandfathered because it's used to be a part of adopted working group document. I appreciate the consideration. We don't need an answer now.
And then you're up next.
Yes.
Right? Yeah.
No, it's not I. Okay, it's not I. Then I will take a pause.
Oh.
Or we can bring mine.
No, let's go ahead and, yeah, we got plenty of time, so let's not confuse the list. Good. There you go.
Okay, this is a next step for the alternate marking methodology. So is a generalization of the alternate marking for any any type of unicast flow, in general, multi-point to multi-point paths. Okay, this is just a recap slide. So you know that as Brian mentioned before, the RFC 8321 has been just published. And there are also some use cases, some application within IETF. In particular, there are 3 documents that define how to use two bits long field to perform the marking methodology in BEER, SFC, MVO3, and also in MPLS to perform an improvement of the RFC 6374 with the use of the synonymous flow label. And then we have also recently an alternate marking variation in Quick, you know. So what are the next steps? There are some performance measurement where a lot of flows and nodes can be involved. So this is a big data problem, for example. The idea is to generalize this kind of methodology. So RFC 8321 works very well for point-to-point flow. But what happens if I have a point-to-multipoint path, or I have a multi-point to multi-point path? So we have to formalize how to take the counter and how to make the performance monitoring more flexible. So this framework is about multi-point alternate marking. We want to add flexibility to performance measurement so we can reduce the order of magnitude of the counters if needed. And this can allow also a flexible orchestration, because the orchestrator can calibrate and can manage the performance measurement in large networks. So the first idea is to introduce the cluster packet loss. So if we have a large network, we can identify a portion of the network. So a group to group segment that we call the cluster. And so the definition is that the clusters are the smallest subnetworks maintaining the packet loss properties. Packet loss property means that the number of incoming packets are equal to the number of outgoing packets. So there is a very simple algorithm that I show you in the next slide. It's a 2-step algorithm. But in general, the cluster can be also combined. So we can perform a partition of the networks at different level depending on the detail we want to achieve. Okay, this slide shows you a simple algorithm to perform the cluster partition. The first step, if we have, for example, this is in this slide, we have a point-to-multipoint path. In the first step, we collect, when we group all the links with the same starting node, with the same A node, B node, C node, and so on. In the second step, we combine the link grouped in the first step with at least one ending node in common. So, for example, we can build in this way 4 clusters partition for the figure. So the second and the third links grouped in the first step are combined because have the E node in common. So this is just an example, but we apply this algorithm also on more complex networks. Another important point that is included in this document is about the delay measurement in a multi-point path. So we know that in RFC 8321, we introduced the double marking methodology to perform the delay measurement. But double marking method does not work in case of multi-point paths. So what is the solution? The solution is that we can consider a single packet delay measurement by using an hashed-based selection of the packet. So that is detailed in an older RFC 5475, that combined with the alternate marking method makes the delay measurement more flexible, because you can use 2 alternatives, a basic cache or a dynamic cache. The basic cache, the alternate marking, split the continuous flows in batch. And so the batch of packets and the marking variation permit to anchor the samples that are selected with the hashed-based selection.
Sorry, we're out of time.
Yeah, okay. This is a use case for this multi-point alternate marking scenario. So as I mentioned before, we add flexibility. So an SDN controller can perform a flow filtering or a cluster zooming depending on the use case, depending on the level of detail we want to achieve. So we can start with the without examining.
Totally out of time.
Okay.
So yeah, let's take discussion on this one to the list, and okay, go ahead, finish off do this slide, but we won't take any discussion on
Yeah,
this.
the last sentence is about the controller that can calibrate, so we can start without examining in depth, and in case of problem, we can detail the cluster, we can make a cluster zooming, and we can perform also a per flow alternate marking performat, but just in case we have problem.
Yep. So please read and comment on the list, and maybe we can bring this in Montreal.
Okay.
Cool. Thank you.
Also now the presentation.
You do? Right. Yep.
Okay.
And go.
Okay, this other draft is also on the same technology, alternate marking methodology, but the point of view is different. So now the scope of the current draft is to make an analysis of the RFC 8321 methods, to introduce new methods that with low overhead, so single bit. Also, what we can use if we have 0 bits for marking. And so in general, the scope of this document is to understand what is the most useful method we can use if we have 0 bit, 1 bit, or 2 bits available. So the background, the RFC 8321, okay, the packet loss measurement is well known, but we can discuss about how to perform the delay. In RFC 8321, there is the single marking method where first and last packet have been used as a time reference for the delay calculation, the mean delay, and double marking. This draft introduces an additional variation, that is the multiplexed marking. So we can have the same resolution of double marking, but we can use the opposite bit of the current batch in order to perform with just 1 bit also the delay measurement. So the timestamp bit is opposite to the bit of the current batch. So in this way, we can use just 1 bit to perform a double marking method.
Yeah, it's almost out of battery.
Okay. Oh, another alternative that is introduced in this draft is about the use of the hashed-based selection. In particular, if we don't have some bit to perform alternate marking method, how we can perform performance measurement. So we call zero marking hash. We use the hashing-based selection to select packet both for loss and for delay measurement. Otherwise, we have the same methodology that I mentioned before for the multi-point. So we can combine the hashed-based selection together with the alternate marking. So this combination is very cool because you can anchor the number of samples within a marking batch. Okay, in this slide, I mentioned before that this document makes a summary of the marking methods technology. And in particular, this is a table that is in the draft and show you with the focus on delay measurement, what are the difference with the difference technology. In particular, the last two rows show you that the single marking hash could be the most complete method because it is resilient to reordering, to packet drops, and it is also multi-point compatible. That is also a good point. So it is very similar to double marking, but it can be considered better if we want to perform multi-point measurement. So as a next step, so the document highlights the marking method strengths and weakness. So it completes the RFSC 8321 experiments. So in particular, you can understand which methodology you can use if you have 0 bit, 1 bit, or 2 bit.
Good. All right. As always, please take comments on this to the list. And again, hopefully we can see this one again in Montreal with some improvement. So this is Greg again. Yes. No, we have one more on Yang models for IOAM, and then actually, because we still have time, Giuseppe, if you and Ignacio want to get up and go back to the conversation that you were going to have on the previous draft, because we have a little bit of time. I'm just trying to hold the lightning talks to 5 minutes.
Okay, I'll keep it. Okay, so this is new proposal. I think we can found a nice catchy phrase, a hybrid two-step measurement method. So what's the problem we see? The quality of measurements in a large degree depends on consistency of taking the measurement. And in our T1 extension, that's one of the things that we're implying, that the method of taking the timestamp. So where the timestamp is taking, that's directly affects the consistency, because if the timestamp is not taking when the transmission or reception of the packet physically begins, then the packet may experience unbound delay, and that will affect the quality of the measurement. So closer to the hardware we take the timestamp, avoiding any queuing, then the better, the more consistent the measurement would be. And that's applicable to obtaining values of counters and other metrics. So, and another is that the measurement information, the telemetry, should be secured. And based on that, if we're transporting the telemetry in clear text, then we're opening it possibility to the man in the middle attacks, queuing it, and thus affecting the scenario that what we discussed earlier with Yakov, discussing their security levels of the stamp. Okay, because now we pay attention to SLA, and it affects how the system being mapped. And if somebody can misrepresent the real picture of their class of service or class of experience present, then it will be unnecessary changes in service allocation and resources, or might be something will be missed, and that will produce unhappy customer.
Yes, hi.
Clarifying?
Just quickly, perhaps you don't need to encrypt, but you need to signature.
Yeah, right. But right, it is.
I made just a proposition to clock synchronization in TikTok.
Yeah, right. We're not talking about what kind of security mechanism. We are just saying it has to be secured.
Okay.
You want me to?
Yes. So what we propose solution? If we take a look at RFC 8169, residence time measurement in MPLS networks, it has defined two modes of operation for RTM capable LSR, one step and two step. So the one step is, as it's suggested by its name, puts the timestamp in a packet that carries PTP control message. And the two step produces the message which has characteristic information that identifies or refers it to the message with a PTP control message, and then transports only and collects residence time. So it collects residence time on RTM capable nodes throughout their path, and that provides on-path support for PTP synchronization, which improves the quality of clock synchronization. What we want to take from this RFC is idea of the two-step method, so that the measurement can be not necessarily to be transported on the packet itself, because then it allows us to read values and then transport them in a separate secure packet with characteristic information which will associate to the packet that triggered this collection. So that's ensure the idea of the two-step method. So we improve consistency and we provide security of the data.
Just a comment in that this wasn't invented for MPLS. This is obviously in the original 1588 spec, the idea of a two-step, right?
Okay. 1588 has a follow-up messages, but when we did it, and basically what we did for MPLS, we included PTP message, whether original or follow-up, in a ACH encapsulation, and then we have a scramble to collect, to accumulate residence time across the path.
Understood. I'm just commenting on your comment that the idea of the follow-up.
Of course. No, I'm just referring to something local to IETF, which has a easy reference point. No, it's, again, yes. PTP has a similar.
Okay. Are you done? Yeah. Okay, cool. All right. Thank you very much. As usual, please read the draft, comment on the list, and maybe we'll see this again in Montreal. So last is Yang data model for IOM. There you go. It kind of works.
Hello, everyone. Here, I would like to propose a Yang data model for the in-situ OM. The idea is simple. We organize the IOM model with as a list of profiles, and each profile will associate one flow with the corresponding IOM information. We use the filter to identify a flow, and there are 4 sub-profiles. Each of them will relate to one IOM encapsulation type. And according to the IOM data specification, the multiple IOM data types can be encapsulated into the same IOM header. And the sub-profiles include the pre-allocated tracing profile as described here, and also the incremental tracing profile, and also the proof of transit profile. Right now, this profile is imported from the proof of transit document. Later, I would suggest to integrate it into this YAM model directly, and also the edge-to-edge profile. That's all for the lightning talk.
Okay. I have a question. Can we roll to the original? So if you have a profile, and these profiles are optional, as I understand, why not to make base Yang model is very lean, enable, and then everything else is mountable?
That's also a good suggestion. Makes sense. Thank you. And we hope this can be adopted as the starting point for the IOM configurations.
Cool. So let's discuss that on the list and reconsider in Montreal.
Okay.
All right.
thank you.
Thank you very much. Giuseppe, did you want to come back up and do the 35 seconds that I cut you off there? Because we do have a little bit of extra time. Wait, which was this? This was this one. And we will go to here. We were here, right? Yeah. And actually, Ignacio, if you had a question, we can do that too, because holding to the 5-minute rule, but we have a little bit extra time, so.
No problem. No, my question is, how do you plan to collect the information? And okay, you put some nice idea to separate in different cluster and so on, but how do you collect the information, and why it's so important to determine if in the previous slide the basic hash, dynamic hash, why is so important? I didn't catch from your presentation.
Okay, you mean the hash-based selection of the packet? Okay. For the collection, okay, you have the reference of the marking batch. So, as in double marking approach, you know the number of packets that can be selected within a marking batch. So it's the same way. If you want to, the problem is that in basic cache,
just you have one collective point, isn't it? Everyone is sending the information, the collected information to one point.
Yes.
And then you process over there.
Yeah.
Isn't it?
No.
This is not clear. This is.
There's alternate marking method does not specify how the measurement results being exported. It only specifies the triggers that being measured. Export of data can be done in IPFix and gRPC in any transport. And the direction configuration of data collector is orthogonal to alternate marking method.
Yes. Yes. And an important issue on this point is about the number. The only problem that you can have with the hash-based selection is the number of packets within a marking batch, because you cannot control the hashing selection as you can control a double marking approach. So, but in this way, there is a dynamic cache approach where you can, there is an iterative algorithm that is detailed within the draft, where you can start to make a selection based on hash, but you can discard the samples in order to have an almost constant number of packets within a marking batch. But this can be detailed. This is detailed within the draft. That if I can describe them more in the next presentation, if I can have more time for the present. Okay.
Good. All right. Thank you very much. That concludes IPPM for IETF 101 here in London. We will see you all in Montreal. Thanks a lot. Yes. What does grandfathering mean?